So I will not have no need to go through this router components. So, but you can connect to a router using any of those ones. You can also use SSH, you can use Telnet, you can use HTTP. You can remotely access a router from a remote location. But what you need to have is, for the switch, it needs to have an IP address. But a switch does not, like I said before, a switch does not have a physical interface, so it has a logical interface, and that logical interface purpose there is just for remote access to the switch, so you can remotely manage the switch. That is why you are given the switch an IP address, and that is the switch virtual interface that was here, and that most of the time people call it the VLAN 1 IP. So the other reason why you are given a default gateway to your switch, so it can also be accessed outside of its LAN. So that is why we. So I hope you're gonna have to answer this if it comes across you now. If you come across it in an exam or interview. Your router's configurations are the same. The basic configurations are all the same. So I'm gonna just do that one in a practical format. So all of these will come into your practical, and I'm gonna have to make sure that I do all the configurations. My configuration will include both version 4 and version 6, sort of a dual stack that I was explaining in my previous video. So we have also some IP addresses that are assigned in your network. For instance, you have the loopback IP. There's a logical IP address that is assigned. Whether it's there or not is not important in some cases, but when you have OSPF that you are going to configure a routing protocol called OSPF or ISIS, they require that you have the loopback, because they're going to use that as their router ID so that it can be identified in the network. Alright guys, so we're not gonna have to waste a lot of time there. So all the basic configuration, how to call it, verifications and so on and so forth. I'm gonna have to come back to all of these in my practical video. So now let's look at the major critical thing here, that is the router forwarding decision. So the primary function of the router is to make sure that it forwards packets toward their destination. So it uses switching function, which is process that accepts a packet on one interface to be forwarded out of another interface up to the other side of the network. So the switching function also encapsulates the packets in the appropriate data link frame type for the outgoing interface. Alright, so the router performs these following steps. One, when a router receives a frame, let's just go back to this one here. Let me just go and pick that. Now, what a router would do is it will receive a particular frame here in a packet and de-encapsulate that. And then it will put it into a new frame or into a new packet. The encapsulate here means it's going to rip this out. It's going to rip the address that conveys the packet right from the switch here. Most of the time it's going to be a MAC address. So when it comes, it's going to rip it off. It's going to now change it. Now it will open it and give it a different address. So that process is what we call the encapsulation. It opens it up, take that address out, give it a new address, and say this is your source and that is your destination. So that is what that ripping off here I mean to say. So that's exactly what this whole thing is about. So the second thing is that the router will now examine the destination IP address of the IP packet to find the path in the routing table. Now this is what we will do. Now I was just explaining this one. The PC here says I want to send something, okay, and I am the source. I have to send something right here, and that is my destination. Now the router would do one thing. It will receive this frame, rip it off, put it in a new packet, and then forward it here to this interface, and it comes here. So before it does this, the router will have to say, oh, this destination, I receive an IP address. What network does it belong to? Okay, it belongs to the 11.0 network. Do I have that 11.0 network in my routing table? Now, this is the question. If I have it in my routing table, I'll forward the packet to destination. If I do not have it in my routing table and the network is directly connected, I am going to drop it. Otherwise, yeah. So this is exactly what happens here in this simple scenario. Then if the router finds a path to the destination, it will encapsulate the layer 3 packet into a new layer 2 frame and then forward it. So from layer 2 to layer 3 and from layer 3 to layer 2 it goes, because this is directly connected, because this network here and that network here are directly connected because they all have their configurations on this particular router. So that is what they mean by directly connected networks. Alright, so that's what I just explained right there. So other explanations when I'm doing the configuration now. So with using the layer 3 IP address, the source IP remains the same until the destination there is no changes. But if it's using the layer 2 frame address, then the MAC address changed from each hop, so it changed from wherever it comes from. So I explained this one before in my previous video. If you go back to my switch concept configure explanation, you will know about that video. Alright guys, so that is just a explanation that is down there. Now when a router is selecting, it determined the best path to the destination network, it involved the evaluation of multiple paths, selecting the optimum. So it has to be the route with the lowest. So whatever the case is, whether it's going to be the lowest hop count, whether it's going to be the lowest metric or the lowest administrative distance, it doesn't matter. So what matters here is that the router needs to know which one of them has the lowest, either the lowest administrative distance or hop count, or the lowest metric in whatever sense it is. So we have different routing protocols that have different ways that they refer to this metric as. Like for instance, RIP or RIP is a dynamic routing protocol that uses hop count. It tells how many hops or how many routers. Hop here means routers. How many, not even routers, but how many of the devices were in this process of encapsulating and de-encapsulating the packet along the way. So it can be any other device, but mostly it's a router that does this encapsulation and de-encapsulation of the packet. So upon this path first, like OSPF uses it as cost, and then EIGRP calls that metric, and you can call it bandwidth, delay, load, and reliability. We'll come to that. Alright, so routers will forward the packet using both paths. So for instance, if you have all the paths to the same destination have the same or has the same administrative distance and the same metric, the router would say, okay, I have two ways to go to Westfield, or I have two ways to go to Serekunda. I can go through Westfield, or I can just go through Latrikunda P-3, but then all of them have equal administrative distance, they all have equal trustworthiness, and they all have equal time consumption. So how long would it take me from here to go to Serekunda? It will take me 2 minutes. If I go through Westfield, it will take me 2 minutes. And if I will go to Serekunda, do I need to ask anybody? No. If I have to go through Westfield, do I ask nobody? No. So that is the trustworthiness. How trustworthy is a route? Okay, that's what the administrative distance is. So this the administrative distance table right here. So each routing protocol has an administrative distance that is specified in this table. So I would ask you people to endeavor and try to understand all these routing protocols and the administrative distance, because we'll come across them one time. So any route that has a lower administrative distance to a particular network, that route is preferable over other routes if there are multiple routes, for instance. So that is what router is. So I was explaining. So the routing table of a router stores information. So how do routers know that this network is there or not? What they do is that routers would check. They have a particular table they call the routing table. That this a cache, is a memory that is stored. It's an information that is stored in a particular memory called RAM, and then this RAM keeps this routing information for a specified period. So what it will do is, if a device wants to send forward a packet to a particular device, either locally or globally, or whether it is directly connected network or a remote network, the router will always have to consult the routing table to ask whether there is an entry for the network for which that particular IP address belongs to. That's why in your subnetting you were doing something like, which network does this particular IP belong to? Because the router also would ask the routing table, which network does this particular IP address belong to? Do I know about it or not? So that's why you were taught how to do that. Okay. So routers learn network in two ways: directly connected network, or because that network is directly connected to it. Like say for instance, I explained that one. This network, okay, this network 10 whatever, and this network, they are directly connected to this